Assalamualaikum and a very good day to you all. In this video, I would like to share with you how to state the basic properties of limits. Okay, so let's get started with the first property. Okay, if we want to find the limit of a constant, over here, sorry, wrong color of pen. Okay, we want to find if we want to find the limit of a constant, this C is a constant. Constant is a number. Okay, it's a number. As x, not variable, as x approaches a. So, by property of limits, the limit is the constant itself. Okay, as you can see, this example, the limit of 8, okay, as x approaches 2, even though the value that x approaches is 2 is different from the value of constant, the limit is still the number of the constant. Okay. Next, the properties of limits, the second one. If we want to find the limit of a variable, this one different lah, of a variable, as the variable itself, this is the same one, right? This one x, this one also x. Okay, we want to find the limit of x as x approaches a value of a. So it equals the value of the approaching value that we want to find lah. Okay, now the example is limit of x. We want to find the limit of x as x approaches 2. So the limit is 2. Okay, now next, if we have the function is a little bit different. Just now it's just x, the previous one. Now we change it a little bit. X to the power of n. X to the power of n. The power is any power lah, any number lah. Okay, any number. Okay, so the limit of x to the power of n as x approaches a is a to the power of n. As we can see here, we just replacing the x. Okay, we just replacing any x with the value of a that we want. Over here becomes a, right? So by using this property, okay, limit x squared as x approaches 2 is, okay, 2 to the power of 2 or 2 squared. Okay, so we simplify it to become 4. Okay, now next property is whereby if we want to find a limit of a combination of several functions. As you can see here, the first function is f, the second function is g. And why I say it's a combination? Because f and g has addition or minus between them. It has plus minus between them. Okay, so how, by using the property of limits, what we can do is we can split them. It's like we expand the limit operator for each one of the function. More or less like lah, but it's not really. By using the properties, we can find, in other words, okay, to find the limit of this complicated function, okay, we can find the limit of individual function first, then we add them or we minus them according to the sign. Okay, that's fine. If you think it's complicated, we just look at the example down here. Wait. Okay, a little bit. Okay, now consider limit x squared plus 2x minus 5 as x approaches minus 2. Okay, so as I said, over here we have 3 different functions. The first one is x squared, the second one is 2x, the last one is 5. And we have a plus and a minus between them. Okay, so by using the properties above, we can find the limit of each individual circle of the yellow circle I've made. Okay, so the first one is the limit of x squared only. Okay, the second one is the limit of 2x. And the last one is the limit of minus 5. Okay, so this one we can use the previous property. Okay, so what is the property? We just substitute the value of minus 2 inside here. Okay, so minus 2 squared. Okay, now this one 2x. X also we can just substitute. So 2 minus 2, like this. And last one is this is a constant. Constant, if constant doesn't matter, x approaches any value, it's the limit is still the constant itself. So minus 5. Okay, so this one is what? 4 minus 4 plus 5. Therefore, the limit is 5. The limit is 5. Okay, now let's continue with the next property. The next property is just now plus minus, right? This time is a multiplication. For this one also, it shares almost the same property. If we have a combination of several functions that has multiplication between them, okay, we want to find the limit of the complex thing. Using the property, we can find the limit of individual function first. Separately, we find the limit separately, then we multiply. Okay, so what is the example? Let's have a look over here. Okay, so what we have this one is our fx, the first function, and then we have the second one. The second one is gx. As you can see over there, it has two brackets next to each other. So this it is the hidden multiplication between them. Okay, so the operation is multiplication. So by using the properties up there, we can find the limit of individual bracket or function first, namely this one, okay, and this one. We find them separately, then we multiply. Okay, so for this one, we just substitute minus 1 squared minus 5. Put bracket first because I want to multiply. Okay, and the second one is minus 1 plus 1. Okay, since minus 1 plus 1 is 0, anything multiplied by 0 is 0. So the limit is 0. Okay. Next. This time, just now is multiplication. This time is division. Now completed already lah. First we've seen plus or minus. The next one we see multiplication. The last one we see division. We see division. Okay, now what the properties say? If we have a combination of fx and gx, fx divide by gx. It has a condition whereby limit gx, x approaches a, must not equals 0. This condition must hold. Otherwise, it doesn't work. Okay. It's just the same as we find the limit of the numerator and we find the limit of the denominator and then we divide them according to the location lah. Okay. Now let's have a look at the example. This one. Limit x minus 1 over x squared as x approaches minus 3. So we separate them. We find the limit of the numerator. We find the limit of the denominator. And now what to do? This one, minus 3 minus 1. Okay, down here is minus 3 squared. Okay, so it's minus 4 over 9. Settled already. Okay. Now, next one. This one is more or less like the multiplication one because we have this tiny dot. This dot also say equal to the multiplication sign. But over here we can see it's a constant. Constant multiplied by a function. Okay, function. So how does the properties work? Okay, if we have this kind of limit, the constant can be put outside. We can put it over here. It means that we find the limit of the function first, then we multiply by the constant. Okay. Now, how to use it? How to practice the properties? We look over here on the right hand side. Okay. We have limit 9x squared as x approaches 10. So we can see the 9 is the constant, right? So we can put the 9 over there, 9 first, and then we take the limit of the x squared first. Okay, so 9 over here lah. So what is the limit of x squared as x approaches 10? It's 10 squared. And then 9 multiplied by 100, therefore 900. Okay, next. I think this is the last one. Okay, the properties of limit whereby we have a square root. Over here is a square root of nth root lah, any root lah. Maybe this means nth root. It means n root lah. Maybe the third root or square root or cube root, or the fourth root, fifth root, and so on. Okay, these properties work more or less like the previous one, the constant one. If we have constant multiplied by fx, we want to take the limit as x approaches a. The constant can put here multiply with the limit x approaches fx, as x approaches a. For this one, more or less the same thing. It shares the same thing. We can take the limit of the function inside of the surd first. The surd first. Then we take the root. Okay. Now how to apply? We look at this example. Okay. As we can see here, this is the cube root. Okay. This is the limit. At first, the limit outside. By using the property, the limit can be inside. Okay. And then we can see over here there are three things lah. Okay. It has three separate functions. Okay. So what we do is, okay, we find the limit of x approaches 2 for 2x squared plus limit x approaches 2, limit 7x as x approaches 2. Alah, panjangkan sikit. Okay. I extend it a little bit. Limit 5 as x approaches 2. This one. And then we take a cube root also. This one we just substitute. So 2 squared plus 7 multiplied by 2 and then plus 5. Okay. So this one is what? 4, 8. 8 plus 14. 8 plus 14. 8 plus 14 plus 5. Berapa ni? 27. 27. Cube root of 27. Which is berapa? Which is 3. Okay. So, I think that's all from this video. I hope it's beneficial. Okay. So, to practice, for you to practice with what you have learned, okay, please do these exercises. Okay, let me zoom it out for a little bit. Okay, I think that's fine. You can pause the video and then take the screenshot of this exercise for you to do it by yourself. Yeah. Okay, so I think that's all. Thank you for your time and attention. Assalamualaikum. Have a good day.